In machine learning, the fundamental challenge involves taking a bunch of objects and categorize them into two or more distinct groups. Is this picture of a horse or is it a car? The SVM support vector machines are one of the most simplest and the most elegant way of classification. Each object you want to classify is represented as a point in the n-dimensional space, and the coordinates of this point are usually called features. SVM perform classification by dividing the objects into separated areas. These areas are separated by line in 2D and plane in 3D. Both of them are called hyperplane. The main concept of this algorithm is to find the best fitting hyperplane that have the biggest margin from all the separated groups. The points that determine the edges of the margin are called supporting vectors. I'm sure that you're not only the theory guy, but you wanna program SVM on your own. Let's hop straight to the code. As a first thing, in all of your machine learning data science projects, you need to import the libraries. We will use 3 of them. I will import NumPy as NP. NumPy is used for numerical calculations, and the NP name is just a convention. As you see other conventions in the upcoming libraries. The second library is matplotlib. From that I will import pyplot SPLT. And the last one, pandas, is used for work with your datasets, like structured datasets that we call data frames, and we will use convention PD. The second thing, I prepared a dataset called car purchases. Here you can see it has 3 columns and a lot of data. And the first column is age of the customer, the second is estimated salary, third one is if he or she bought a car or not. And our model will be predicting the future customers. We need to load this dataset into a variable called dataset. I will do it with the pandas library, pandas.read CSV file, comma separated. And the name of the file, as we saw, it is car purchases.csv. And now we will be training our model, so we need to divide the whole data set into input data and the data we want to predict. So the independent variables and the dependent variables that depends on the independent variable. So x will be the matrix of the independent variables. I will divide the whole dataset using the ilog function. It is integer location, and in these square brackets you can specify with these double dots. It is not called double dots, but I will call it like that right now, and it will take from the start to the end all the rows. So now it is all the rows, and from the start and excluding the last column, because it is our dependent variable, and we need the values from that. And while will be the values we want to predict, so dataset, ilog, square brackets, all the rows, and only the last column. And also we need the values. Now we have our data prepared, but that's not all. We need to divide that x and y into small parts, because we want to train the model on some of the data and test on the rest of the data. That means I will import from sklearn that model selection one model. This is called train test split. As the name says, it will split the data into testing set and training set. That's all. Xtrain will be our training input values. Xtest will be the testing values. Same for the y values, y train and y test. and I will use the train test state function, put there our datasets, and I will use two more specification in this function. It is test size. I will put here 0.25. That means 75% of our x and y values will be used for training and 25% will be used for testing, and the last one will be random state. It is equal to 0. This ensures the reproducibility of our code, because it will produce the same results every time you run the code, not only for me but also for you at home. Yeah. If you want to test out your program, you can bring out the dataset, for example the input dataset, like this, and you can see I haven't stored the program. Run again, and as you can see, here are the train dataset. You can print out also the shape of the dataset, and you will see there are 99 rows. Save and run the code. You see 99 rows, 2 columns. You can print out the X train shape, then the X test shape, and you will see it will give together the value of our all input data. You see 74 plus 25 is 99. Everything is alright. Now move on to the next part. We will be standardizing the data, because we want from our data that every value will have the same impact. If 10 of our values will be 1 or 2, 2.1, and next 10 will be million, that every data won't have the same impact. So we need to standardize our values from sklearn preprocessing, import standard scalar. The standard scalar, the instance of this class, will be stored in the sc variable, and what this does, it will calculate the mean of our values and also the standard deviation, and after this, from every value it will subtract the mean and it will be divided by standard deviation, and it will give us the value between 3 and -3. The mean will be 0 and the standard deviation will be 1, but it doesn't matter. So I need to use this standard scalar to my data, my training data, because output data is 0 or 1 if it carries both or not. Yeah. So xtrain is equal to sc.fit transform, fitting the standard scalar. That means we are training the standard scalar. A transform method is used for transforming the dataset xtrain, and we need to use this standard scalar also for training dataset, not training but testing dataset. sc.transform is, and we will put the x test, and we do not need to put here also the fit method, because we need to get the new values. If you use I will record more detailed videos in the future about the SVM with the more complicated projects and also the math behind the SVM. So you need to trust me right now. Okay. The next thing is the main part, is training the SVM module. So from sklearn.svm import vector classifier, like this. Okay. And the classifier will be stored, the instance of this class will be stored into classifier and will be svc. I will define the kernel is equal to linear, like this. That means that kernel that will be dividing the values into the groups, as you saw in the introduction video before this code, it will be linear combination of our input variables. As I said, more details in the upcoming videos. Let's move on. Kernel linear, and the random state will be also 0. Next thing, we have the module for our classification, but we need to train it on our data. So classifier fit means train in machine learning, and we will put here x train and also the y value for our training dataset. Why it is so? Because SVM is supervised learning algorithm. We need also the labels of our input data, otherwise it won't work. And that's all. Now it is trained and it should be working, so we will test it out. Here are our data, and I will predict one data with this module, and then I will predict all the data, and we will see the percentage of the correct answers produced by our model. But first of all, I will predict only one value. Print out the classifier predict sc transform. We need to transform that value also. Transform double square brackets. I have absolutely no idea why. Double square brackets here, and copy the value. For example, here, this one. It is a human with 35 years and estimated salary of $65,000. Copy and paste here. Run the code. Wait. Yeah, predicted value is 0, and I will run it twice, so twice 0. It will give the same value every time, so it doesn't matter. So it is working, and now it is time for final testing. We have just predicted one value. Now it's time to predict all the values. I will store this result into variable called y_predict, and I will use the classifier we trained, and I will predict with this classifier our X test set. Last but not least, we need to print it out, so I will print it out as a NumPy array. I will concatenate, that means put together two arrays. The first one is our real values from the testing dataset, and the second one is our predicted values right here. So I will concatenate it by putting here y predict, reshape. I will reshape all the arguments here to be one column and all the rows. So I will reshape it. Number of rows will be length of that array y predict, like this, and it will have one column. I will concatenate it with the, as I said, with the real values. So y test, also reshape to the length of the y test, and the number of columns will be 1. All this will be put together on the columns. That's the one and the end. So it should be working right now. I will print it out. We will see the occurrence of our model. So first, this is our predicted one value, and the first column of this NumPy array is our predicted values, and the second one is the real values. So as you can see, here is one mistake, but all this is correct. And here is second mistake, and others are correct. Now we can make better decisions in our Mercedes company, or we can go eat a lunch. It's up to us now. But our code come to end, and we are happy that we did it together. So in the next episode we will go to the more details of SVM. I want to thank you for watching this video. I hope you enjoy it, and smash the like button, hit subscribe, and peace. Tschüss.